Rate laws and units of K. The rate laws need to be determined by experimentation. Once each reactant involved in a reaction is tested for its effect on the rate, the rate equation can be written. This is what we call the rate equation. Now, in the rate equation, you have a variable representing the concentration of the reactants, and you have a variable representing what effect this reactant has on the rate of the reaction. If this variable is 1, it's a first order with respect to that concentration. If this variable is 2, or either one of those variables is 2, m or n, then it has a second order effect. The overall order of a reaction is the total of all these numbers. So if you have 1 here and a 1 there, then it's a second order reaction. If you had a 2 here and a 1 there, it's a third order reaction. The effect of, let's pretend this number here, x is 1. If this is 1, it's first order with respect to a certain number, to a certain reactant, and if you double the value of x, it doubles the rate of the reaction. If on the other hand, the value of m is 2, and you change this number from a 1 to a 2, then if you put a 2 here to the power of 2, you get a quadrupling of the reaction rate. So second order reactions quadruple when you double the concentration of that particular reactant. You can read through that on your own. When experiments are carried out, only one substance is changed at a time in order to observe the effect the change of concentration of that one substance has on the reaction rate. And you'll notice that when you do kinetics problems, you'll have at least 3 data sets: reaction 1, reaction 2, reaction 3. And what you do is compare only one change while the other ones all stay the same. So that in science, that's called control. You only change one thing at a time, and then you observe what effect that change of one thing has on the rate of the reaction. Let's look at the units of K now. If you're ever asked to find the units of K, you'll start off with a abstract rate equation. Rate is equal to the rate constant times the concentration of some substrate we can call A. Usually the rate of a reaction is measured in moles per liter per second. Sometimes the mole per liter part here is a big M, and they'll say molarity per second. And in this case, I wrote out each individual unit of molarity. So molarity, moles per liter per second. The rates of units of K we're trying to find, so we left K as K, and the concentration of the substrate is moles per liter. I transpose the units of A, so I can isolate K, and we get seconds to the minus 1. So if you see seconds to the minus 1 for the units of K, that's a good indication that it's a first order reaction. In a second order reaction, the reaction, this exponent is 2, or you can have 2 exponents, each being 1. Both of them are considered second order reaction. So again, same setup, moles per liter second, values of K, that's what we're looking for, and then the molarity per liter, or moles per liter rather, squared, rearrange it here, and then what we do is we take this fraction and turn it over and turn it into a multiplication so we can more clearly see the units that are left over. And what we get is liters per mole second. Another way of stating liters per mole second is to put them all in the line and put a negative exponent on the ones that are in the denominator. So that's why you get to the minus 1 or minus s to the minus 1 and mole to the minus 1 here. But this means the same thing. Lastly, if you have third order, the rate is equal to K times the concentration of A cubed, or you could have A squared times B, or you can have A times B times C. All those possibilities are real. Here's the rate units. Here's the substrate concentration units, but to the power of 3, so we distribute the power of 3 in there. Then we take the result and flip it over, so we can turn it into a multiplication, and it simplifies to liters squared times mole to the minus 2 seconds to the minus 1. For higher order reactions, it is necessary to derive the units of K by rearranging the reaction. And that concludes how you find units of K.